In exercise 504, we look at scientific notation. Now, please just be aware that scientific notation is different to significant figures. In scientific notation, we're not always rounding a number. You might get a question where you're asked to write in sig figs first, which is rounding, and then write in scientific notation. But on the whole, scientific notation is not rounding at all. All it is rewriting very large numbers or very small numbers in a different format. What that format is 1. You must write it as a number between 1 and 10. So you might be starting with a number like 10 million. And 358,260. Really big. But you've got to reduce it to a number between 1 and 10. I'll show you how you do that. Just be aware that your number that you reduce it to must not be smaller than 1. So it can't be a decimal between 0 and 1. And it can't be 10. Between 1 and 10 means it can't be 10. So the biggest it will be 9.9, etc. And then, because we know that 30 million is not the same as 3, then we've got to show that we're going to also multiply by a power of 10. So it's multiply by a power of 10. Okay, let's have a look at this first example. This is a very big number, 234 million. To write that in scientific notation, I'm just going to follow the 2 steps. 1, write this as a number between 1 and 10. So we use the digits that we're given. However, we write it, in this case, as 2.34. So it can't be 0.234 because that's not bigger than 1. It can't be 23 because that's bigger than 10. So I've reduced 234 million to 2. Now we know they're not equal. The way that we say that they're equal is to do this multiplying by a power of 10. Now I've got to choose the power. I've got to choose the number, the correct number that goes in that spot. Now the number that goes in that spot represents the number of places I need to move this decimal point. So it's like I've put the decimal point in here and I've got to move it 1, 2, 3, 4, 5, 6, 7, 8 places. If I don't move it 8 places, then these two numbers are not equal. That equal sign is extremely powerful. For me to be able to say that that number is equal to that number, then I must say this decimal point here needs to be moved 8 places. And because it's a positive 8, it means that decimal point gets moved in that direction, which is correct. The decimal point is on the end. Okay, what about a very small number? Again, 0.00567 is a very small number. But to write it in scientific notation, I'm going to make it big. I'm going to make it a number between 1 and 10. I use the digits that are there, and in this case, the number will be 5.67. Now we know something that's smaller than 1 is not equal to 5, but I will need to be able to say they're equal. So I need to do multiplying by a power of 10. Now remember that I said previously, the number that goes up here represents the number of places this decimal point needs to be moved. So it's like this time I've put the decimal point in here, but I really want it to go back 1, 2, 3 places. The fact it's going back is a minus and 3 places. So that's how we can write a very large or a very small number in scientific notation. You often get questions where you're given a number in scientific notation and you have to write it as an ordinary numeral. So to write it as an ordinary numeral, we're just going to move the decimal point the number of places that the power of the 10 suggests. So in 1.23, you can see I have to move the decimal point 4 places, and because 4 is a positive, I will move it in that direction. So it becomes 1, moving the decimal point 1 place, 2 places, 3, 4. Or you might do it like this, 1, 2, 3, 4, and realise that you've got 2 spots to fill in with zeros. So in its scientific notation format, it would be the number 1.23 times 10 to the power 4. And that equates to the ordinary numeral 12,300. With the next one, 3.5 times 10 to the minus 3, we're going to move the decimal point back 3 places. Why back? Because that's a negative power. So from here we're going 1, 2, 3, and that's where the decimal point goes. So you can see I would need an additional 2 zeros, so we get 0.0035. So when the power of 10 is positive, when the power of the 10 is a positive, move the decimal point to the right. And when the power of 10 is a negative, you move the decimal point to the left. Now, in this example, you can see that we're going to write it in scientific notation and then round it to 2 sig figs. Let's see what that looks like. To write this number in scientific notation, I have to follow these steps. 1, write it as a number between 1 and 10. So this becomes 3.54780 times 10 to, well, I've put the decimal point in here, but it needs to be 1, 2, 3, 4, 5 places. So we want it to the power 5 and a positive 5. Now, we've now got to deal with the 2 sig figs. 1, 2, we'll be cutting this number off there. 2 things, don't fill in these places with zeros because it's after the decimal point, and that's what we learnt back when we did sig figs. And cutting off a 4 will not impact on that 5. So it's 3.5 times 10 to the power 5. Please write down your summary points and do the questions from exercise 504.